Welcome back, boys, to another episode of Low Spec Labs. This is episode 2 on our R8CSA series. So chapter 2 covers basic shell skills. So that includes creating aliases, knowing the difference between internal and external commands, how to ask for help for various commands, as well as redirecting input, output, and standard error on the command line. Thankfully, I have created TikTok/YouTube shorts explaining all these topics. So we're going to use those videos. Past Steven has you. I've already done the thinking. Now all you have to do is listen. Okay, let's go ahead and start with internal versus external Linux commands and how they work. I've already done this via YouTube shorts/TikTok, so I'll hand the mic over to Past Steven. Go ahead and handle it from here, bro. Let's go over internal versus external Linux commands. The main thing to remember here is that internal commands are part of the Linux kernel, so they're baked into your Linux install. And the key thing to remember is that external commands are packages you either write yourself or download from the internet, whether that be GitHub or from one of the repos. This is exercise 2-1 from R8CSA Cert Guide EX200. Step 1, log into your host. Step 2, click activities. From there, we're going to search TERM for the terminal. Step 3, run time ls. This shows us the ls command and how long it took to run it. Step 4, run which time. And what this does is it shows you the current location of the time executable. It's at user/bin. Step 5 is to run the time command by itself. What that does is shows us the command is available to the shell. The next step is to echo the path variable. Remember, variables are case sensitive, and all the folders listed here are locations the Linux host will look for external commands. Hold on, I thought you said earlier time was an internal command, and it is, but there's also an external version of time. If we run time versus user bin/time, we will get two different results. That is step 7. So remember, boys, time ls is different than something like user bin time ls. And as you can see, we got two different results because there are two different executables that technically put out two different outputs. Time is different than time. One of them is a built-in utility. The other one is a more advanced application. So when you're using Linux, you need to know about standard error, standard input, and standard out. Once again, we're going to use TikToks to explain those. So let's talk about standard output, standard input, and standard error a little bit more. Standard output sends the output of a process into a file that's readable and usable by you. Standard input is a file that the process is monitoring that allows inputs either from the user or from other processes. And standard error obviously is what the process uses to print out its error files. Let's go ahead and let's keep talking about Linux redirects. So in the last video, we learned that 0 standard for standard in, 1 stands for standard out, and 2 stands for standard error. We're going to see how we can use that to directly redirect standard out and standard error on our command line. One thing I like about Linux is that the engineers that design it are high enough on the spectrum to keep things practical and simple. For instance, if you want to redirect to standard out on the command line, you simply do this, right? And if you want to redirect to standard error on the command line, you simply do this. Now let's see how that works. Last time we wrote a Linux script called script.sh. Let's see what's in that script. As you can see, it echoes hello world, and then it tries to cat the output of a file called file.txt. Let's modify it so it errors out. We then change this back to not a file.txt. And what we're going to do is we're going to send the output of standard error to our command line. So let's see how we do that. So let's start with a simple redirect. What we can do is we can do script.sh, and then redirect all outputs from script.sh to out.txt. And then when we cat out.txt, we'll see the standard output went to out.txt, but standard error did not. So what if we wanted to send standard error to out.txt? Well, first we're going to want to clear out.txt. So, and then save it. Right, cool. So we've cleared out.txt. What we then do is we run the script again, and we add a 2 to our output. All right, and as you can see, it ran hello world, and then when we cat out.txt, we can see our error got dumped to that text file. So by default, it dumps standard out to the text file if you redirect. But if you include the 2 right here, it'll dump standard error to that text file. So what did we just learn about Linux from those 2 examples? Well, we learned that by default, when we redirect, with no additional signs, it's going to send standard out to whatever we redirect to. If we add a 2 to our redirect, it's going to redirect to standard error. Now that we've learned the difference between standard in, standard out, and standard error, let's work on a lab where we discuss that topic a little bit more. Past me, it's your turn again. For another Linux exercise video, we are tackling exercise 2-2 and RHCX A9 EX200 by Sander van Voigt. Truly, I stand upon the shoulder of giants. I can pretend like I know what I'm talking about here. Step 1, open a shell or terminal. We've already got that done. Use the pwd command to verify your home directory. So we're in home LSL. Step 2, we use the ls command to list the contents of our directory. Step 3, we redirect the standard out of the ls command to dev null. So that's ls redirect dev null. As you can see, we got nothing. That's fine because it's expected behavior. Step 4 is to ls a file that doesn't exist. So we'll do that, and then we'll redirect standard out to dev null. And you can see we got standard error, or we got an error message because that file doesn't exist instead of no message. Step 6 is to redirect standard error from that previous prompt. So we just have to add a 2 there, and all of a sudden the error message disappeared because we sent the error to dev null. Step 5, if we add etc to our ls, you can see we didn't get an error message, but we also got the contents of the etc folder. Step 7 is to send the output of that previous command to out.txt. Basically, we're going to dump this into a file. And you can see we got nothing, but when we ls and then we cat out.txt, we see our contents listed there. Step 9, we can do echo hello, and then we can do out.txt. And then when we cat out.txt, you can see the file has been cleared because the single and operator overwrites everything in a file if we write it to a file. Step 10 is to ls and then append that to out.txt. And then when we cat out.txt, you can see we now have the contents of the ls once again. Step 11 is to list ls-R/. This will list all files and folders on your Linux host. We hit cancel or Control-C to stop the scroll of messages. Step 12 is the same command, except this time we pipe that command into less. And that lets us scroll through all the files easier. And then we hit Q to quit, which is step 13. And step 14 is ls pipe/dev tty. We can then try to redirect ls to dev/tty1 for step 14, and that'll fail because this user doesn't have the right permissions. Now that we've learned about pipes and redirects, the next portion of the chapter talks about Linux history. So the Linux history is a log of all your commands you've entered in your current terminal session. Let's dig more into that. Let's talk about the Linux command history. The history command, like its name implies, keeps a log of all commands you typed into your Linux terminal. First, you type history to get an overview of the commands you've already used. As you can see, these are my old commands. Step 3 is to add some lines to the history. ls
pwd
time, and then clear. Then we open a second terminal on the server. So if we run history in this terminal, then we run history in this terminal, you'll see we have two different histories. That's because your history session is kept locally to your terminal. What if we close this old session and run history again? This time it shows the entire history list. So remember, history only gets saved at the end of your terminal session. Until then, it's in temporary memory, or you should consider it in temporary memory. What if we want to search through old commands? Well, that's step 6, using Control R. And then we can type ls, and you'll see the first result is ls/etc. So Control R lets you search through commands. Another way to search through history is to pipe history to the grep command. That is step 7. And as you can see, it shows us all the results with ls. If you pay attention, each item in history is numbered. We can actually use the exclamation mark and the number of the command to run that command again. So if we were to run exclamation 72, it runs that command again. Once again, past me is doing lots of heavy lifting in this video. Whoa. Anyways, let's continue to part 4. Bash completion. Exercise 2-4, bash completion. Bash is the most common Linux shell included with Linux distros, and the default shell for RHEL. You can compare bash completion to autocomplete when you're typing on your phone's keyboard or in something like Microsoft Word. Let's start the lab. Step 1. Try typing in GD and hit tab. As you can see, command not found. So because the command wasn't found, it couldn't autocomplete. If we were to hit G and just hit tab, we would see all 171 commands that start with the letter G. We can get more specific with bash completion by typing more characters. For instance, if we type GDI, you see we only get one command, and that's gdisk. We can also use bash completion on files as well. For instance, we can do cd/etc/firefox. As you can see, it starts to finish as we type it in. And for step 5, let's go through that one more time with the cat command. So we can do cat pass. As you can see, bash completion printed out.txt. That's a quick video, boys. Thank you for watching. That is on bash completion. Next, they'd like you to know how to use Vim, which is a built-in Linux text editor. So let's go ahead and watch the video on that. If you're following along, we're now on exercise 2-5, how to use Vim. Before we get started, I'd like to remind you that Vim/vi is a command line text editing utility and is normally included in the Linux kernel of most Linux distros. Let's use Vim to create a test file and play around. vi test file.txt. And with that, we have Vim opened. For us to enter text, we must hit I, and you'll see we entered insert mode down here. And then we can enter text like cow, sheep, dog, cat, chicken. To save those changes we just made, we hit escape, :W to write changes to the file. If we want to go to a specific line of text in the file, we can do escape, :3, and that'll take us to the exact line number 3 in the file. If we wanted to delete a line from the file, we simply hit DD. If we want to undo that deletion, we hit the U key, and you can see the line got undeleted. We can also use the O key to start a new blank line. We then enter some more text at the current cursor position. The last step is to search for and replace aux with uppercase aux. To do that, we're going to use the search command. Here's how we work it out. Modulo S search / lowercase aux, and then we're going to want to replace it with uppercase aux, and we're done. And as you can see, aux changed from lowercase to uppercase. Now let's talk about environment variables. That's also something you have to know to manage the shell. Let's dig into that. We just echoed the path variable. What is a path variable? Well, the path variable is one of what we would call environment variables on Linux. Variables on Linux systems are fixed names that can be assigned dynamic values. To get a list of environment variables, we use the env command, or an env. Your environment variables are controlled by several files: /etc profile for all users, /etc basrc for subshells. So these are applications that you open up and then they have like another shell or command line inside of them. Local.bash profile affects only local shells, so they would affect only your current user, and local.basrc would affect only your current user and local subshells. So now that we know what they are, let's walk through a lab to learn how to use them. This lab is based off RHCSA 9 Cert Guide EX200 by Sander van Voigt, exercise 2-6. Hopefully you have a shell open. We then echo the lang variable. As you can see, it's set to US UTF-8. Then we run a ls-help, and that gives us some information about the ls command. Now let's set our language to Spanish. To do that, we can do lang equals es_es.utf-8. Now we run ls-help, and you'll see the language has changed to Spanish. Let's open up a new terminal. We can do that just by clicking this, and then when we do echo lang, you'll see our language is once again set to English. That's because we didn't change any of the environment variable files. So because none of these environment variables were touched, our language environment variable went back to English. Okay, let's use Vim to edit our local basrc. And then we want to add a variable there, and that variable is color equals red. And then we hit escape, and then we save and quit, and then we verify the variable is set by doing echo color. We're not quite done yet. We've set the variable, but if we were to do an echo color, we get nothing. But if we were to open a new terminal and then we were to do echo color, you can see we now have our value red. So it's set the variable, but it only loads the variable upon the next login or the next instance of the terminal, because it only reads that file as you're launching the terminal process. Last but not least is using the help command, or finding help about using commands in Linux. Let's go over that, and then that's it, boys. Welcome back to another episode of Low Spec Labs. Let's talk about man some more. So in our last video, we talked about searching for help using man and grep. Let's dig into using man a bit more. Step 1, log in. We've already done that. Step 2, try to search man page for a partition. ART. There we go. And we now see the results from us searching for partition in man. What if we want even more information? Well, as an example, we can do man on man. And then inside of man, if we hit the / on our keyboard and we search -k, it'll bring us down. Oops, let's try that again. -k. And you can see it gives us even more information about that command. So you can do that on any other command as well. Sometimes when you search man, you might not get any results for what you're looking for. This normally happens after you install an application. That's because your man database is out of date. To update your man database, you would do sudo mandb. Because to update mandb, you do have to be an admin account. And as you can see, our database is updated. And that's it. Thank you for watching another episode of Low Spec Labs. Talk to you guys next time. So if I've managed to keep your attention for this long, I would like to say thank you. I sincerely appreciate you taking the time to watch these videos. Remember, your silence is enthusiastic consent, right? That means you're loving this. So I'm going to keep putting out video content like this. Please feel free to hit the subscribe button below. You guys have a great day or afternoon or wherever the hell you watch this.